All right, part 2. Let's finish this lesson up. Okay, so we just talked about how we can look at slope and talk about increasing or decreasing or no change, as well as shallow and steep lines. Let's keep going now to look at some contextual situations that might not have numbers on the graphs. Okay, so we're going to take a look here at graphs A, B, and C in the example. They don't have any numbers on it. That is okay. We can still interpret them using the knowledge we just talked about. Whoops. Okay. So I'm just going to zoom in here a little bit. There we go. Perfect. And let's write in these blanks. So we know that a line going up and to the right, okay, represents something that is increasing, right? We know that slope value that is positive represents something increasing, and we also know that a positive slope has a line going up and to the right, so we can put those together, knowing that a line going up and to the right means increasing, and then similarly that a line going down and to the right represents something decreasing. Pardon me. Sorry, ladies. Okay. And we also know, lastly, that a horizontal line is something that's unchanging, right, or constant. Okay, so that's just kind of an extension from the last page. Wow, this is not going well, you guys. I'm sorry. Okay, let's try that one more time. Unchanging. That's definitely my worst writing so far. I'm really sorry if you can't read that. Just let me know. I'll clarify it for you. Okay. So we are going to look at these 3 graphs given here, and they each represent the amount of gas in the tank over time. We're going to interpret each graph by giving a possible situation for each. Okay, so we can see that in this first graph and in the second graph that both lines are going down and to the right, so they're both decreasing. Okay, so if it's helpful to write yourself a little note saying decreasing, then feel free. That might help you to figure out kind of what the context of the situation is. Now, if you take a look again at the same 2 graphs, A and B, we can see that even though they're both decreasing, graph A is going down at a faster rate, right? It's much a steeper line. So that means that the rate is quicker, right? So whatever's happening is happening faster because we got down to the same level here much more quickly. Okay, and so maybe this situation is the car, whatever vehicle we have, is driving quickly. Maybe that's what's happening. Okay, so the vehicle is driving and using maybe a lot of gas, right? So that's a very plausible explanation for what we are seeing here. Oh boy. Okay, a lot of gas. That's what I'm trying to write. All right. Okay, the other option, or the other scenario, I guess, here with graph B, is we can see that the line is still going down, but not as quickly. So it's possible that the vehicle then is driving at a reasonable rate, right? We might have just kind of like a medium speed and using gas at a medium rate. Or maybe we could say a medium rate. Okay. And I guess for graph A, we should add that the gas is being used up quickly as well, to clarify that it is in particular being, the level is going down very fast. Okay, last but not least, we have graph C. Now we can see that that is a very flat line. Okay, and so this situation could be, sorry, I'm just trying to find my eraser, there we go, could be that the car is maybe idling or something like that, where it's not really, sorry, let me rephrase that. The car could be just sitting, that's the word I was looking for, because we can see that the amount of gas here is just staying constant, right? So that means that the amount of gas is not decreasing in the tank. And so because of that, the car can't actually be moving, right? If it was moving, then there would be gas being used up and you would have a decreasing line like B or A. But because that's not happening here, then we know that the car must be just sitting, right? It's not moving, okay? And so we can say that the car or vehicle, whatever word you want to use, is not moving because no gas is being used. Okay, there we go. So that's that example. Let's just take a scroll down here to the next example. All right, we're going to answer these questions now based on that graph down there on the left, okay? And so we can see that the question is asking us to first identify in A which line or lines are increasing and which line or lines are decreasing. Okay, so I'm just going to change colors here. Let's see, that's a nice color. Okay, I'm just going to split my up here into two sections so we can write all the increasing lines here and all the decreasing lines here. Okay, and so increasing lines, remember that means a slope that's positive, going up and to the right. So if I take a look here, I can see that very clearly line T is going up and to the right. It is going in that increasing direction, so that means that line T would be in this section. Now, how about line S? So that is going down and to the right, even though not very quickly. It's still going down and to the right, so that puts line S in decreasing. And same logic for R. R is going again down and to the right, this time very quickly, but still down and to the right. And so then that means that R also is a decreasing line. All right, so that's question A. Question B asks us, which line represents the fastest rate of change and how do we know? So remember that a very quick rate of change will be represented by a steep line. Okay, so we're looking for the steepest line that is here. And if it were me, I would argue that line R is doing that, right? So line S is very shallow, as you can see, and line T is kind of somewhere in the middle. It's a little bit steep, but a little bit shallow, right? It's kind of medium, but it's very clear that R is quite steep, okay? So R represents the fastest rate of change because it is the steepest line. And then we can say that steep lines represent quick or fast rates of change. Okay, there we go. And then question C is kind of the same question, but the opposite, which line represents the slowest rate of change. And so using the same logic we just used for question B, but in reverse, we're going to look at which one is the slowest rate of change, so which one is the shallowest line, the least steep. Okay, so we kind of talked about this already. It's pretty clear that S is very, very shallow, and so that would make S our shallowest line. So S represents the slowest rate of change because it is the shallowest line. So this is the opposite reasoning from B because we're looking for the opposite feature. Then we can say shallow, there we go. Let's do some better spelling, hey? Lines represent slow rates of change. Voila. All right, let's go to the next page. So we're going to put this all together now, okay? So we're going to start by looking at a table of values, and then we're going to graph the data on the coordinate plane that I provided here, and then we're going to calculate the slope, and then talk about what the slope means, okay? So back in the 2000s, which is when I was a kid, although I was actually like a small kid in the 2000s, and then I became a teenager towards the end of the 2000s. We used to have cell phone plans that charged per text message. Yeah, for real, which sounds crazy. But I wanted to make an example as a little bit of a throwback for me. So it used to be that if you texted, then you would get charged per text message, and that was crazy. So in this example here, I just made up like what could be a graph or a set of values for that kind of usage of a phone. Of course, I don't know if this is exactly true, but this is the idea. And so we're looking at number of texts compared to total cost. Okay, so we're going to first graph this data on the coordinate plane that I've provided for you here. And I just want to remind you that when we're doing that, we want to start by figuring out which is the independent variable and which is the dependent variable. And we talked about that like quite a bit in our statistics unit. So if you can't draw that to mind right now, or you're having a hard time remembering, I would really recommend you go back and look at those notes, because you will need to know that here. And so if we take a look at this number of texts versus total cost, we can see that the number of texts that you send will determine how much you pay, right? Because it's the fact that you're getting charged per text message, right? And so however much you text will determine how much you're paying. And so because of that, then the number of texts is the independent variable, and the total cost is the dependent variable. Okay, so remember that the dependent variable always goes along the y-axis, and the independent variable always goes along the x-axis. So we're going to do that. So I'm just going to zoom in a little bit here so this is as neat as possible. And we're going to write that in, okay? So we're saying that number of texts goes along here. And I'm going to turn my screen around here and then write along the y-axis that we are talking about total. There we go, total cost. And if you look back in the chart, here, I'll just scroll up quickly. You can see that the total cost has a unit associated with it, which is dollars, and you always want to include that if that exists, right? So again, kind of thinking back to our statistics unit that we talked about, you always want to have a unit where possible. Okay, so those are the two axes, right? And then we need to put some numbers on them, right? And so we can see that both start at 0, both the number of text and the cost start at 0, so we're going to need to include a 0 on the graph, and I'm going to do that just down here at the corner. That's probably too similar. Let me just choose a different color. Let's do orange. Okay, so 0. So that's going to be, this point here is going to represent 0 on each axis. Oh, shoot. There we go. Okay. And then we can see that on the dependent axis, we need to go up to 13, right on that y-axis. And on the x-axis, we need to go up to 65, okay? And so it is up to you how you would like to do your axes usually. I am going to go up by ones on the y-axis, okay, so I'm just going to go 1, 2, 3, etc. And then on the x-axis, I'm going to go up by 5, so 5, 10, 15, and etc. Okay, so I'm going to zoom in here, again, to make this as neat as possible. We're going to put those in numbers in, okay, so I have 5, oh boy, 5, and then 10, and then 15, and then so on. Okay, so you know you don't have to put every number in like we also talked about, as long as you give an indication of, oh, that's fun. As long as you give an indication of what you're kind of aiming for along the axis, then we're good. Okay, and so same thing on the y-axis, I'm going to go up by ones. But I, again, don't have to go all the way up. If I don't want to, in this case, I might actually, because I just don't want to count later. But again, if you chose to just do the first couple, that would be totally fine. Okay, so here we go, almost at 13. Voila. Okay, and so now I am going to look back and we're going to make some points. Okay, so I have 0, 0 is a point, so I'm going to draw that on the graph here, just down in the corner, right? So that's 0, 0 right there. Okay. Then the next point I have is 25, 5. Okay, so I'm looking here at that second row, 25, 5. And so I'm going to need to figure out where's 25 on the x-axis and then go up 5 for the text cost. Okay, so 25 will be right here. Okay, and then I'm going to go up until I get to 5 and put my point there. Of course, I'm going to erase all those little dots that I made. Okay, perfect. And then, oh, that's not what I meant to do. Sorry, guys. There we go. Okay. And then I'm going to go back up here, and I'm going to do my last point, which I can see is 65, 13, okay? And so we're going to go back to the graph, and we're going to put that on there, and then we're going to have to count across, okay? So I know I didn't label all of my points, but I'm going to have to count across. So 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, okay? So I know that 65 is going to be along here. And then I'm going to go up again, like I was saying the last time, up, 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 until I get to 13, which is right there, okay? And, of course, I don't want to leave all of those things on my graph, so I'm going to erase those all because those are not helpful. All right, perfect. So now we have a neat and tidy graph, well, as much as possible with this bad stylus. Hopefully yours are very neat and tidy. That would be great. Okay, and there we go. That's a graph. And then the last thing we need to do, of course, is put a line through the points because, as you might imagine, if I were to send 10 texts, I would still have to pay for that. Or if I sent 15 texts, I would have to pay for that as well. Even though I only pick certain points on the table of values, I still need to be taking into account all the text in the middle that I would have sent, right? To get all the way to here, to 65 texts for $13, I would have had to send 64 texts and 63 texts and so on. And so I need to draw a line through my points to represent that, okay? There we go. Okay, my line is not going to be exact. I'm going to warn you right now that this stylus situation is like poor at best for drawing lines. And so that line should actually be going through exactly all 3 of these points. And I know it's not, but just use a ruler on your pages and make sure it does. And then the last thing is I want to put an arrow at the end to show that the more I text, the more I pay. Okay, so the line would extend the more I text. All right, and then the last thing that we forgot, or you might have forgotten, but here I am to tell you it, is the title. Okay, so cost of texting in the 2000s. That's what I wanted to call the graph, so let's call it that. All right, so now that we've made this graph, we've labeled it, we have all of our pieces there, we're going to calculate the slope. Okay, so like I have told you guys many times, we're just going to use rise over run where possible in this unit because it's so much easier than using that silly slope formula if we don't need to. Okay, so rise over run. That does not look like an N. There we go. And so in this case, let's find those 2 numbers. Okay, so remember that you can pick any 2 points. I'm going to pick 2 points that we have. Okay, so I'm going to pick this point and this point. If you wanted to pick any other points on the line, that would be totally fine. Okay, all right, so we can see that we want to find the horizontal distance change and the vertical distance change. And remember that we're always starting at the left point and going to the right point. So if I were to count up the graph here, wow, that's super messy. Let me try that again. Just going to zoom in to do that, actually. There we go. Okay, so if I were to go up the line here like this to count, you can see that I went up 8. Okay, so I went from 5 to 13, so that's up 8. Okay, and so then I can put 8 in my rise spot, and because I went up, it's a positive 8. Okay, oop. Okay. And then I'm going to count my run. Okay, so now I'm going to go from my left point to my right point again. So from the left point spot to the right point spot, going across here. Okay, you can see that that's starting at what the equivalent of 25 is to the equivalent of 65. Okay, and if you're wondering how I got those numbers, it's because I'm going off of these 2 points right here. Okay, so I know that I went from 25 to 65. And going from 25 to 65 is a run of 40. Okay, so I'm going to put that run value down here in my calculations. Okay, and so then I'm going to reduce that, okay, or I'm going to put it in my calculator. In this case, we're going to put it in our calculator just for ease of calculation. Okay, and that's going to give us a value of 0.2. Okay, so let's talk about what does that slope mean? What does that 0.2 represent in this case? So remember that we're looking at the cost of texting in the 2000s, and we have the total cost and we have the number of texts, but we don't have the cost per text. And remember that rate of change is what we're showing, right? We're showing how much did it cost per text. That's what the graph is, the data is showing us. Okay, and so then we can write that out. So the slope, oh dear, let's try that again. Represents how much it cost to send a text. Text. So cost per text. This means it cost 0.2 of a dollar, right? 0.2 is the value we got, and we knew that our unit in the graph was dollars. Okay, and so it means it costs 0.2 of a dollar, which is 20 cents. Okay. To send one text. Oh, how things have changed, hey? You guys don't pay per text ever, but it used to be that way. So there we go. So that is the end of this lesson. Okay, I will put up some sort of worksheet for you guys on interpreting slope on shallow lines and steep lines and all that kind of thing. It might take me a couple days to get it up, but I will do that for you. And then you can work on it from there. Okay, if you have questions about any of this lesson, let me know. Of course, I'm available to talk with you guys via Teams, so just message me on there if you have questions. Okay, take care of yourselves. Talk to you guys soon. Bye.